going to fill up with epoxy. So I'm going to cut this open. And it's going to make it articulate here. I'm not going to cut it all the way up to the part line. I can't because the fixture's in the way. But I can come very close. And I can certainly go far enough that I know that as I go further later, I'm not going to cut the inside skin yet. I'll wait, let that go. I'll let it partially cure, and then I'll cut through the interior skin as well. So I'll make that right now. And I took the screw out of my leading edge, and that's why the fixture is moving around. I'm going to go ahead and cut this all the way through, right up to the back of the fixture. Back with you in a moment. Okay. We've removed the screws, lifted up the trailing edge just enough to slide this tape in there. That was fun. And put the screw back in place. Now this is the super hot, super thin, super glue. It wicks right underneath the surface. Careful, because it's going to wick on. It's going to wick. It will go right onto the carbon fiber. That is all we're going to need on those surfaces. Now we did the same thing. Swing to the inboard end there, please. Right here. Did the same thing here. You notice how this lifts up easy? Piece of cake. So we'll wick some super glue. Maybe I'll just lift this one up and put the drops of super glue down. Stick it down. We're done. Back with you in a moment. Watch him. Okay, here we go. I've just put the nozzle on here. You can use flax, mix it up, and put it into a Ziploc bag, cut off the corner, and apply it. But this is the method I choose to use because I'm lazy. Okay, follow me to here. I'm going to put some of this material on you notice how it stands up? What's nice about this is that it holds its shape. It's like hair gel. And it allows me to put it on things like a wing rib that is in the vertical on the winglet. And it won't droop or run like phlox would. We'll be back with you in a moment. Okay, hold it still. Okay. Now, so I've mixed up the material and I'm applying a thin wetting to the surface. Do the same thing to the rib. Now, time is not your friend at this particular point. We're going to move along rather quickly. Get everything wetted out. Do this to every mating surface. And what you saw me applying to that board, you see me using right now. There's an interesting viscosity. You keep me in frame there, Devin?
Yep.
I have my 8-year-old son doing the video work, being assisted by the mad Russian Svolich Mishka. So, all right, this is going to be typical. We'll show you what this all looks like when we're all done. All right, we're back. We have coated everything. Trailing edge, all the ribs, all the longitudinal members. You can see the green hue on everything. And trailing edges, all the ribs, top of spar, false spar, inboard end, leading edges, everything. And what you haven't seen yet is the interfacing surfaces on the opposite skin are also completely covered with some margin of safety built in, wider influences of resin on the opposing skin because I can't inspect it after I close it. Okay, I got my young son again working on the camera, and I've got the tube here. I haven't got a lot left. You can see in here. We're going to put a bead down that I'm absolutely certain is going to be large enough to cover when it gets squeezed. Now I have a bead here I'm going to have to do too, but it's going to be a smaller bead. Follow me, Devin? Okay? This is in excess of what it's really necessary. Now, because of the diameter of this, sometimes I'll have to come back and squeeze this. In this area, it's not a primary bond, because the glass later on is going to be the primary load-bearing material in this area. I don't want big goobs. I'm going to do this all over. We'll be back to show you as we progress. Okay, follow me. This is one of the quality that's best about this thing is that you can put a thin bead on and it holds its shape and its position wonderfully. I can put a small amount on, or I can put a large amount on. So do the same thing up here. I may be in the way of the camera at the moment.
No.
Okay. It's okay to let the tip ride on there. I think I can probably do a better job of putting on a narrow bead by doing that than any other way. I'm going to put epoxy in here because I want to go around this wire. Okay. And,
Okay.
yep. Okay, we're done with that particular section. Oh, a second, let's let it go a second. Now this is a very, very, very critical bond. So we're going to put a bigger bead in here than we know we're going to need. And of course a spar. This bead's going to get larger and larger and larger as we get towards the end, as it gets wider. We'll be back in a few minutes to show you some more of this. Shoot, okay. I noticed that I've got a flush here and I've got a little step there, which means that the back end of my shear web sagged here. So I've lost some of my contact here, so I've got to increase the size of my filler in this area if I want to make certain I don't have any gaps. I'm down to the end of my tube. Now then, when I hit the end of my tube, I hit this, here, keep it squeezed, pull. And with that pulled, then I can remove the containers. I'm going to keep my nozzle. This is a throwaway. We're now into 1.5 tubes. Make sure you have at least 2 tubes available to you for your bonding operation. We'll be back with you as we do this area here. This was not potted before. This should have been. I should have potted this area with phlox and let it cure up so that I had a thin film to do, and I wouldn't have to try and fill it oversized, because there's about 10, 20 thousandths gap in here, and I'm going to have to put a lot of material in here to make certain I get a bond. Back with you shortly. Okay. We're going to brush a little resin, regular straight resin, Jeffco, 206 if you wanted to, 105 if you were ambitious. And then I'm going to come across here like this, into this area. I'm going to brush resin on the upper skin, the same place. And if this is really dry micro, I will be thrilled to death. Not dry enough. Okay, stop. Okay, at the top, show the top end, Devin, all the way up, all the way up. Full coverage, trailing edge, all these members here. Now remember, we've cut this so that we can clear this out after we squeeze it on. And come on down the winglet, plenty of material, leading edge, the ribs, all the surfaces, well into here, and that nice material down the trailing edge. Okay, go on down the spar, Devin. Okay, go down the spar. You don't want to be too close up, Devin. Give it.
Yeah.
Okay, now go on down. Oh, too slow, and
I'll
okay.
go back again.
All right, that's what it's supposed to look like. I'm going to give you a zoom in on a few things. Look at how much material I have on top of the spar, but that's because I've got more gap than I really wanted to have. I should have pre-potted that before. Okay, there it is on this end. You can see the nice bead on the trailing edge. Okay, now on the inboard, on this end here, I brushed on the resin. I want to create a dam here. I'm going to make certain it's wetted up underneath here, because the purpose of this whole thing is to make certain that water can't come in here and end up inside my wing when the nose is parked down.
I want to get a massage. Okay.
My son is becoming Cecil B. DeMille. Okay, Devin, is that clearly visible?
Yeah.
You just... Okay, make sure that it's nicely wetted. You know you're going to get extra squeeze. That's okay. And it's completely wetted on the inside, plenty tall. Now I'm going to go wet the opposing surface, and we'll be back with you in a moment. Now you're going to notice that this is not particularly easy. Misha, you're going to handle the torsion. When I let go of an edge, don't let it twist. Okay. This end, and this is the hard end. What we're going to do is we're going to make certain that the leading edge goes on in this. Devin, watch the screen. That the leading edge goes on in this fashion. Otherwise, it comes straight down. It'll wipe the leading edge. I also have to make certain that the winglet goes against the surfaces without wiping as it goes against the surface. Okay, let's slide her on back. Up. Line me up there, Misha. Okay, slightly forward the leading edge. Okay, good. All right. Set. What am I caught on? Okay, good. Slide. All right. We're on. We have a lot of extra material. You can see it squeezing up through here. Devin, you follow me. Follow me. Squeezing up through here. I don't want too close up, Devin. And now, don't squeeze. One of the things you don't want to do is do not squeeze anything until you are prepared to make it so that when you squeeze it down, it stays where you put it. Now, when you start squeezing, you have weight ready, or tape ready, or clecos ready. You put it someplace, you make sure it stays there. Okay, now, I think one of the first things I'm going to do is I'm going to put the screws in this portion of the wing. And get that tightened up. All right, you can continue here. Here we go. Actually, I think what I'm going to do is I'm going to put the clecos in the leading edge first. And we'll be back with you in a moment. Okay, you notice that, look down the leading edge, Devin. Look down the leading edge, and you look at the screen to see it. You notice the tape. I want you to watch me. I've got about 1.5 feet on the back here. A lot of surface area, all right? And I pull like crazy. We're probably talking 40, 50 pounds. And then I pull back. And can you see a little bit of squeeze that it's occurring right there? And I'll give you the whole process on me. The This is the really tough tape. This is not the wimpy stuff that you see so much of. Okay, let's go in about right here. Rub it well onto the bottom. And of course, make certain that your surfaces are clean. Pull and pull across. Good bond line. Make sure they're well attached. And you're not going to want to do this in a room where you're going to then heat it. Let it cure some before you think about putting heat on it. Your tape will soften up and then you'll lose your pressure. Okay. Pull like crazy, way close to the top. I think did you see the squeeze on occur? Okay, good. So I've got one more here I want to do. We've got the main spar weighted pretty well. And okay. All right. Okay. Do more of the same. We'll be back. What we've done is we've clamped this inboard end with a 1" by 2" extrusion, and we've put drywall screws through, and you can see the squeeze out here. Massive amount of it. Let's see if we can get squeeze out to occur here. You drill the number 40 drill bit. Squeeze. Okay, we get really good squeeze out there. We've got plenty of weight on the top. We're clecoed into position. Check your dimensions. Give me a sweep on the whole wing, Misha, and show them how much weight we have on this thing. And leading edge is well prepared. And I can easily look up inside my aileron to see whether I got squeeze out here. We have all the screws on. All we're going to do now is clamp that trailing edge. We've weighted the trailing element right here. 2 clamps to squeeze the trailing edge. I got lots of squeeze out here. You can see I have lots of squeeze out in here. Misha, show them the squeeze out at the end of the tank if you don't mind. It's going to take you a little bit of a setup. We'll back with you in a moment. Are you giving?
I'm showing right there. On the tank. Here's the squeezement in the tank.
Yeah, they won't be able to hear you because now I got the microphone. All right, you can see there's the squeeze. Wow, it's really progressing. There's a lot more in there now than there was before. We're going to wipe that out so it's a nice clean squeeze out. We're also going to come in here with a squeegee and remove the excess there. And I've got the same kind of condition inside the end of BL23 here. You can't see it, but Misha will show you what it looks like, and he'll also show you an area where it needs to be squeezed some more, like right here. I'm going to push. There it goes. Right here, Misha, you were fine. Right here, down. You're too close. Okay, right there. I'll squeeze. Whoops. Probably need a little more weight right up in here. Okay, there it is. It's coming out. One of the reasons that we didn't make the bond areas any wider than they were is that the amount of resistance it creates is tremendous. Okay. We'll get in here with squeegees and remove the rest of it. Okay, that's how much was removed from right here. A bunch. Now we're going to go up inside here. Excuse me. Pardon me. And see if I'll need a tongue depressor for that. We'll be back in a moment. All right, we've finished assembling this wing. There's a few things that I may not have covered during the assembly process. One of them was the use of this bar. And as you can see, it's just a little over 33 inches in length. It's drilled with 3/16" holes. I used 4 of them. I clamped this end with duct tape over it first so I wouldn't get any bonding. Clamped it here, and then screwed through here. And you apply the screws based on the squeeze out that you get. If you need more holes, you have a bunch of holes in there already. about 1 every 5 inches or so, and then use the ones that you need. I drilled, and once I got it in place, I drilled through these holes with number 40s and then ran my drywall screws in and pulled it up until it was dead flush and flat, and the squeeze I got was tremendous. Then I capped this fitting after cure, and I stuck a piece of 1/4-inch tube on it and stuck a piece of glove over top of it. A balloon would work just fine. And a rubber band, I would prefer that because the glove was it had so many laps in it that it leaked around here. But it held for many, many hours before it lost, and it had very little pressure in it. So you can blow into this thing, fill up the balloon, and then cap it closed before the balloon shrinks down too far, and you can leave it overnight. It will expand and contract with barometric pressure and or temperature. This is still green. I've sanded off this material. I'll cover this with 2 plies of bid. I could go as many as 3 and then sand into it, but probably only going to do 2 plies of bid, leading edge all the way down to where the joggle ends. Sand it clean first. If you don't want the dust to go inside the wing, put a little air inside it so that the air is flowing out, but I wouldn't worry about that. Sand it while it's green, sand the leading edge, 2 plies of bid plus or minus 45, you're done. Take a large syringe. You can usually get them at plastic marts and places of that sort, and fill it up with a loose mixture of West 105, 205 micro, and then insert the ends into the holes and fill it up until the stuff squeezes out the opposing sides. One of the real good reasons for making certain that the hole went all the way through when you did your first drilling with a number 40 drill bit. That way when it comes out the opposing side, you know there are no voids in the foam and that the hole is completely filled. Leave a little left on the outside, and that can be sanded to a flush surface on the top. Do that all the places where there are holes, that'll be done. The next thing I'm going to do here is, while this material is still somewhat green, I'm going to take a bandsaw blade or hacksaw blade and pull it through here to create a gap all the way to the part line. Follow the bulkheads, because the bulkheads are not positioned. Remember, they're positioned at 85 degrees. So you won't be following the part line. Follow the gap that you cut on the opposing surface earlier on in the tape. I can't think of anything else to cover at the moment. We're back to you. Good evening. We're back, and we have removed the wing from the jig. You can see there in the background, it's freestanding. It's all set. And now what we've got is the fixtures placed where they were before. Something you can't see at this particular point. We made this process a lot simpler. Okay, we're going to come around the end here. I'm going to give you a view down the back end here. What I did was I started off by just taking the aluminum extrusion and marking it on either side at each rib position, which makes it really simple for me to reposition the fixtures. The original fixture positions were on the red line. You see right there, just about 4 inches off of each one. I made certain that each one of these new fixtures is perpendicular to the trailing edge of the table, just like we did before. You can see that black line right there, and a black line on that one, and the back line on that one, right on the edge of the table, etc., etc. That one's not quite as easily visible, pardon my shaky hand, but everything else is essentially the same. It's symmetrical and in very close to the same positions before. The primary reason for doing that is that we lost the room on this end of the table. Sorry about that, we lost cable. There's that original red line, and that put these legs out in space. So I had to move the whole thing over just a little bit. But we're very close to where we were before. So there we are. We've got the fixtures back exactly in the same place they were before. There's those black lines again. Black lines again, you can see them, making it really easy to just reverse the whole fixture. Now remember that the left wingtip was right there on that end. Well, now we're going to put the right wingtip in the same place, and we're going to set the trailing edge just as it was before. And I'm about to go outside and grab Michael Schuette's other wing skin. You can see standing up there up next to Richard's airplane. Back with you in a moment. Good morning. We've trimmed the right wing skin, and we've set it on the fixtures. And what I want to do is show you how this wing fits the fixtures that were actually evolved and developed off of the left wing plug. And we'll go to this middle one here first. Okay, you notice the fit. There, all the way back here to the trailing edge. And I'll take this back here, and we'll go to the... we notice the word datum there. That is, remember, it was reversed. It's the inside surface that's the datum now. There is less than a 32nd of an inch between the two surfaces. And part of that is created by the fact that this taper here is now the opposing direction that's up on the edge. So you can shave off the bevel up here in the front. You won't find it back here, but the taper ratio will change and exacerbate the condition back here, but it's so small that I don't think I'd even bother. Let's look at the inboard here. Okay, nice fit, and the furthest inboard, spectacular. So, proceed, trimming and fitting. We're going to cover this little section right here. You notice this. See this up and down? We're going to put a little support out here so that the weight of the winglet doesn't cause this to move quite so much. And we'll cover that with you in a moment. I talked a moment ago about this edge. Back in here where the surfaces are all flat and in plane, it's not going to make any difference. But as we get further and further forward, we begin to see the effect, the exacerbation of this angle by the sweep. If I allowed this to come all the way up and around the leading edge, which is why I limited the templates to somewhat short of the leading edge, it would bump the leading edge at different places, left and right wing. So this outboard edge right here, especially up near the front, is actually going to possibly lift the wing up at the front. It's the only portion of this process that is exacerbated by the thickness of your fixture. The narrower your fixture, the less asymmetry. Obviously, a knife edge is going to sit the same place, so the left wing is at the right wing. But the wider you get, the more effect it's going to have up at the front. So we're going to remove this portion and leave this inside edge untouched. Now I'm coming over to here. Do the same thing with just the front up here in the front. And again, as I said, don't change this edge on the inside surface. We're going to leave it alone. No problem here at all. Nothing on that inboard end. Now we're just going to take that off. And we'll fit this and back with you in a moment. Okay, here we are Thursday morning with nothing but controversy and confused individuals about what happened during the elections. And here we are, we've cut off the end of our extrusion. You remember the extrusion was stuck way out here where we cut it off and made it a lot easier to fiddle with. And we've clamped it in place because this piece right here can move up and down. You want to get it into essentially a no-load condition where it's not sagging and it's not pushing up the trailing edge. And I'll bring it around and show you this side. I may have covered this a little earlier, but I'm going to cover it again and show you what I've done with it. You can see the clamp here. All right, this is what I'm talking about here. I don't want it sagging, and you'll be able to tell if it's sagging. It's sitting firmly against this piece of aluminum, and you're 5 inches from here to the inside edge of the template. Oops, let's pull it out here. Okay, 5 inches from this corner there to here. Template's firmly down. This is clamped to the piece I cut off. And make sure it's in a no-load condition. I've already sanded this entire interior surface. We're going to get ready to go on here with what we did on the opposing wing. And the only reason I'm showing you this portion of the tape is that I want to cover the things that might be slightly different than your last process. And the leading edge is most certainly one of them. circumstances beyond my control, created a single joggle leading edge on this wing, not a double. You remember on the other wing, we had a depression and then a depression here as well. Well, we're going to put the other wing skin right on top, and you're going to lay up 2 plies of bit around the outside, one long, one short, and then you're going to surface it. The only difference between the two is 26 thousandths of an inch of glass, which will not substantially affect the lift generated here. If you're really concerned about it, template the leading edge of this wing after you're done with the 2 plies of bit and tapering it back in a fair curve onto the upper surfaces, and fill and surface your wing on the other side to match it. There will be no differences in structure. It's just that I don't have a joggle for this one. The tooling that I was using to produce the double joggle was destroyed in the oven while I was not here. So my apologies, but it will not have any effect whatsoever on the final structure or shape.